All right. So I'm actually going to start this problem by graphing it, because I would just like to know whether or not I'm headed in the right track as I go along. So f of x equals x cubed minus x squared plus 1. And the domain on this, right? Well, we're going to talk about the domain, but I've given you an interval here. I said I want the extrema over this particular interval. So that is telling me, I'm going to use a little squiggle bracket there. -1 is less than or equal to x, which is less than 2, not less than or equal to, just less than 2. So here is the graph of my function, and well, and I can see that I have a little valley right here. I know that this endpoint up here is undefined, so that is not going to be an extrema. You can't have an extrema if there's nothing there. But this endpoint over here is defined, and that is also going to be an extrema. Endpoints are always extrema. Okay, so so I kind of have a picture of what this looks like now, and I'm gonna start working the problem from a calculus standpoint. So my domain here, let's call in somebody to kind of get you engaged a little bit. Oh, Zian is not here. The only person that's not here, and I pull her out of the hat. Nicole. Okay, so here's the function. Do you see any denominators?
1, but
Where?
oh, denominators?
Yeah. See any fractions here?
Not really.
I don't either. So I don't need to worry about that for my domain. I got no denominator, so I have no variables in my denominators. How about radical signs, Nicole? You see any radical signs in this?
No.
Yeah. And what about logarithms? You see any logarithms?
No.
I don't see it. So the domain of this function is all real numbers, perfect blind date, except that I defined the domain as -1 to 2. So that is the only domain issue I'm going to have with this function, is what I defined. Is everybody okay with that? Now I want to point something out. I might define a domain, but there still might be a denominator or a radical sign or a logarithm as part of the function. So just because I've defined the domain doesn't mean that there might not be other spots in that domain that are undefined. Should I say that again, or was that clear? Come on, guys, gotta get a little response here.
Can you say it one more time, please?
Yes, I can. I'm going to actually give you an example here. Let's just say that I was doing the function 1 over x minus 1. And I wanted that over the domain of -2 to 3, both endpoints. So I kind of know what that function looks like. It looks like, it looks kind of like this, with a vertical asymptote right here at x equals 1. Are you with me still? Okay. Now, if I only want this function from -2 to 3, means I don't care about this part of the function and I don't care about that part of the function. Those aren't part of my domain. You still with me? Right? But within the domain that I am looking at, it's quite possible. I mean, it's a fact that x equals positive 1, the function doesn't exist and the derivative doesn't exist. So that would be something I would have to take into consideration. So what I'm saying is, just because you find that there are endpoints, you still need to look at the whole function and look for don't ride lions, okay? Denominators, radical signs, DICAL, with an even index, and logarithms. You still got to check for those. Okay, but in this case, there aren't any of those. The only domain restrictions is what I said here. So now I'm going to find the derivative. And that is 3x squared minus 2x. Everybody okay with that? Yep. And the domain of my derivative, well, also, I don't see any denominators. I don't see any radical signs. I don't see any logarithms. So the only thing that's restricting my domain is the fact where the function doesn't exist. So the domain of my derivative is going to be the same, -1 to 2. Now, the reason we're finding the domain is to discover whether there are any endpoints. And the next problem that we're going to do after this one, you'll see why that becomes more of an issue. Okay, but so now I have my function and I have my derivative. My extrema happen either where the derivative is 0 or where the derivative does not exist. So where does this equal 0? I'm going to factor out an x, and I get 3x minus 2. So I am going to have a derivative equal to 0 where x equals 0, and where x, well, if I go 3x minus 2 equals 0, 3x equals 2, where x is equal to 2/3. So there are two places, two x values, where I may have extrema. These are where I got to look. One is where the x value is 0. The other is where the x value is 2/3. And there's a third one. There's a third place I have to check for extrema. What is it? Somebody tell me. Just unmute and tell me.
The endpoint that is included.
I gotta look at this endpoint -1. -1. So those are the x values that I have. And now I'm going to find out, well, what are the y values here? Now I'm looking for the y values in my function, because if I go back to my picture here. Come on. Please, would you please cut me some slack here. There we go. Okay. The extrema that I have, and I didn't even notice this one here at 0 and at 2/3, those are on the function. So I need to find the y value of those on the function. So I mean, I can see from my graph, it's going to be 1 and 0.852. So I'm going to go back here to my problem here. And if I plugged in 0 into my function, I'd have 0 minus 0 plus 1. So that is clearly going to be 0, 1. And if I plug 2/3 into my function, well, you know, I'm actually feeling a little bit lazy right now. No, I'm not going to be lazy. I'm going to do it right. So let's do it. So I'm going to go 2/3 into my function. So I'm going to go f of 2/3 is equal to 2/3 cubed minus 2/3 squared plus 1. So that is equal to 8/27 minus 4/9 plus 1. Everybody still with me? Doing okay? All right, good. All right. So I'm going to make everything into 27ths. So I'm going to multiply this by 3/3, and I'm going to multiply that by 27/27. So I have 8/27 minus 12/27 plus 27/27. So that is a -4 plus 27. That would be 23/27. That is the y value where x is equal to 2/3. So 23/27. And then I need the y value of my end point here. And that I can probably do in my head if it's -1. So this is going to be -1 minus +1 plus 1. So -2 plus 1, it's going to be -1, -1. These are the 3 points where I might have extrema. And I'm going to go back and look at my graph and say, well, here's one right here. Right, -1, -1, that's good, I'm happy with that. Here's one here at 0, and is 0.852 23/27. I don't know, I'm going to look because I like exact values. If that's a decimal approximation, I don't want it. So 23 divided by 27. Yes, that's a decimal approximation. It's an 8.51851. Oh, looks like it's 851 ongoing. That's interesting. But I'm going to call it 23/27. So these are the 3 points where I think I have extrema. Are we okay with this? You sure? No questions. We're good. All right. Well, now I'm going to go to my number line. So I have here's 0, and here's a 1, 2, 3, -1, -2, -3. And I have intervals that I need to check. I need to check the interval here from -1 to 0, and the interval from 0 to 2/3. These are the x values that I'm plotting on my number line: 0, 2/3, and -1. And since my function ends right here at -1, I can actually, I don't really even need to look at this. And it ends over here at 2. So I don't even need to look at that. But I do see that I do have another interval. So I have 1, 2, 3 intervals that I need to investigate. Is everybody okay with that? That I have 3 intervals I need to investigate. And I'm investigating my derivative. So between 0 and -1, I'm going to use like 0.5. And between 0 and 2/3, I think again I'll use, I'm sorry, this is -0.5. I think I'll use +0.5 here. And between 2/3 and 2, I'm going to use 1 as my value to test. Is everybody okay with that? Yes, we're good. Questions? No? I'm doing all right? Okay, well, negative 0.5, 0.5, and 1. I'm going to go over to my Desmos here. And so am I going to, I'm asking a question. The question is for Karina. Karina, am I just going to do right here to find the value? Am I going to go f of negative 0.5? Is that what I'm going to do?
Yes.
No. No.
I don't.
Yeah, you had a 50% chance there, but you wasn't. Why? Okay, I'm not going to do f of negative 0.5. Why not? Somebody tell me. Why not? Why do I not want to find f of negative 0.5? Magic bowl. This is a question that kind of determines the heart of this whole extrema issue here. Karina, again, I don't think it's worthwhile to ask you again, do you? Not yet, not yet. And Zian, it's not worthwhile to ask Zian because she's not here. So how about Grace? Why am I not doing negative f of negative 0.5?
I'm not really sure.
Okay, Grace, so I want to push you just a little bit, okay? I'm going to go back to the problem here. And do you understand that why I made these, why I set these intervals, negative 1 to 0, 0 to 2/3, and then 2/3 to 2? Do you understand why I have those intervals? Or if you don't, say no. That's okay. I'm seeing uncertainty.
Could you explain again?
Yes, I can explain it again. Are you okay that the only possible places that I can have extrema are where where the derivative equals 0 or the derivative does not exist? Are you okay with that? Are you sure? Is everybody else okay with that? Yes. Okay. So Grace, I identified where my derivative equals 0. There's no place that it doesn't exist except at this endpoint over here of 2, but I also had to have the point of the other endpoint. So it's where the derivative doesn't exist, where the derivative equals 0, or an endpoint. Are you okay with that? Yes. Okay. So that's why I identified negative 1, 0, and 2/3. Those are the only possible places that I can have extrema. Are you everybody okay with that? We're good. Okay. Now, if I want to know whether an extrema means a minimum or a maximum, so let's go back to my graph right here, and you can see on the graph, I do have a maximum right there where x equals 0, and I do have a minimum right here where x equals 2/3. And I also happen to know that my endpoint, I'm going to put my endpoint on here just so that we have a nice looking at it. My endpoint, which is negative 1 comma negative 1. I bet you didn't know you could make an endpoint like that, huh? That's pretty cool. Those all to me look to be extrema. Don't they look to be extrema to you? Are we okay? Yes? Okay. But in order to determine whether they're minimums or maximums, I have to look at the slope of the function on either side of those points. If I had a point that I knew was either a minimum or max, just because I know the point, I don't know whether it's a minimum or maximum. But if I know the slope going up to that point and the slope going away from that point, then I can see, oh, well, this is a max. Can you see what I'm saying here? If I had another point here, again, just because I know the point might be an extrema, if I know I have the slope going up to that point is a negative slope, and then away from that point is a positive slope, then I know I have a minimum. So it's the slope on either side of those extremas that is telling me whether it's a maximum or a minimum. I will say that as many times as you want me to say it. Is there a question? Somebody want to, Grace, you're still looking a little bit confused. Speak up. No, you're good. Everybody good with this? Yes? Okay, now I'm going to ask you, this is not related to the problem, but I'm going to throw a little curveball at you here. What if I have a point that has a derivative equal to 0, so f prime of x equals 0, but the slope on this side of the point is positive, and son of a gun, the slope on this side of the point is positive. That's not going to be an extrema. That's going to be like a pause. That is actually, if I look at the graph of x cubed, the graph of x cubed looks like this. And right here at the point 0, 0, the derivative of x cubed is equal to 0, but it is not an extrema. It's just a little pause. Am I doing okay here? Yes, I'm seeing yeses. Okay, good. So back to here, the question that I was tormenting Karina with was, I'm using this point, negative 0.5 and positive 0.5 and 1. I'm using those to find the slope in that interval. These are the places where I might have extrema, but I need to find the slope in that interval. And I can pick any number in that interval, find out the slope, and that is going to be the slope of that entire interval. I can't change slopes from positive to negative or negative to positive unless I have an extrema. And I've already determined the only places I can possibly have extrema are 0, 2/3, and -1. So Karina and everybody else, I want to put this number right here, -0.5, into a function that's going to tell me is the slope positive or negative. And the derivative is the slope of the tangent, is the rate of change. So if I plug that -0.5 into the derivative function, that's what's going to tell me if it's positive or negative. Are we doing okay? Yes? Okay, so I'm going to go back to my Desmos here, and I'm going to say, well, let's g of x equals d to dx of f of x. F of x. Come on, Mr. Jenkins. F of x. So there is my derivative function right here. And you can see that I have a derivative of 0 at 0 and a derivative of 0 at 2/3. Everybody with me? Right. So I kind of confirmed my algebra from before. So I want to find g of -0.5. And that turns out that is a positive number. G of -0.5 is a positive number. So in this interval right here, it's going to be positive. And then what about g of positive 0.5? Let's do that one. So g of positive 0.5, that's a negative number. So I'm going to have a negative in that interval. And then, well, my derivative, where x equals 1, I can just look at my derivative and see that it's 3 minus 2, so that's positive. So I should have a slope that goes positive, negative, positive. I should have a maximum here, a minimum here, and then at this end point here, it is also a minimum because the function is going up from that end point. Let's look at the graph. Let's just look at the graph part. The graph part, I said, not the derivative part. Well, it looks to me like the slope of my function is going up here from the endpoint. It kind of has a maximum right here. Then it goes down a little bit, just like it says over here. And then it goes up. So my point 0, 1, that's this point right here. Come on. This point right here, 0, 1, is a maximum. The point 2/3, 23 27ths is a minimum. And the point -1, -1, my end point here, is also a minimum. And looking at the graph, this point right here, -1, -1, that is the lowest point on the graph. That is an absolute minimum. It looks like I have an absolute maximum, but I don't, because the point right here at 2 is undefined. It's not part of the function. So the answer to this problem is this right here. And you know what you need to show when you're doing the problem is basically all this calculus and algebra, including the number line piece right here. You really need to show me the number line piece to kind of get this problem right. Now, Nikki, I think you said before the last session, you weren't clear why we were plugging these into the derivative. Are you clear now? Yeah, everybody clear on that? I want to find the slope. I'm going to use the derivative. And in order to tell whether something is a maximum or minimum, I got to know the slope on either side of that point. Pretty good? Just loads of fun. Like you know, it's more fun than a barrel of monkeys. Have you heard that expression, more fun than a barrel of monkeys? Yes, people have heard that expression. Okay, that's good. I don't really know if a barrel of monkeys would be really all that much fun, frankly. I guess it kind of depends on the monkeys. They could be like violent monkeys, you know, or they could be kind of fun monkeys. I don't know. Okay. So what time is it? It's 12:15. Oh, we got all sorts of time here. All right, so we're going to do, this is a more complicated problem. Not that much more complicated, but just a little bit more complicated. So let's go to the magic bowl and say, okay, so Victoria, well, how would you like to start this problem? What do you think we should do to start this problem?
Find the derivative of it.
Oh, great, let's find the derivative. Okay, so do you want to help me do that? This is f of x. Can we rewrite this some way, Victoria, that makes it easier to find the derivative?
1 over 1 minus x squared to the 1/3.
Yes, to the 1/3 power. I think so. everybody okay with that? Yes? Okay, get rid of the radical signs, turn them into fractional exponents. I'm going to make it even a little bit easier to find the derivative here, because if I do it like this, I got to use the quotient formula. And I don't like the quotient. I don't like the quotient rule. Too many pieces. So I'm gonna change it. I'm gonna change it to 1 minus x squared to the negative 1/3. How about that? Pretty good? Is everybody okay with that? Yes. All right. Now, it's really nice that this function was written like this to start with. But if it had been written like this to start with, you could make a mistake very easily. You could look at this right here that I just underlined here in purple, and you could say, because I'm trying to find the domain like Victoria wants me to do, you could say, I don't see any denominators, because I don't see any denominators here. Do you see any denominators here? But there is, because it's a negative exponent, right? You can see in the original function, there's absolutely a denominator there. Everybody see it? Somebody is calling me, and we are not going to answer the phone because calculus is more important. Whoever it is, unless it had been my mom, in which case I would have answered it, but it wasn't my mom. Okay, so be careful if you have a negative exponent, that indicates that there's a denominator, so you got to be careful there. All right, so I see that there is a denominator. So I'm going to find the domain using that denominator, and I know that in order to do that, I have to take the denominator, which is the cube root of 1 minus x squared, and I have to say that cannot be equal to 0. So let's cube both sides. And I get 1 minus x squared cannot be equal to 0. So I get negative x squared cannot be equal to negative 1, or I can just say x squared cannot be equal to 1. Is everybody with me still? Okay, now again, I'm going to tell you, you have to pay really close attention, because the tendency is to do just this and then to say, oh, I'll take the square root of this both sides, so x cannot be equal to 1, and then that's my domain. That is wrong. Okay, so anybody know why it's wrong? Oh, Megan, why is it wrong?
It has to be plus or minus 1.
Well, okay, so this is very interesting. So Megan is saying, and this is a good point, I take the square root of both sides, it has to be plus or minus 1. Right, so the x cannot be equal to plus or minus 1. Well, that implies, okay, so let's think here. If this is my domain, then that implies that my domain of this function would be negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. Now I'm going to pause right there. I want to make sure everybody really understands what I just wrote there. I will say it again. Somebody want to ask a question? Come on, guys, speak up. We're all happy with that. Okay, so if we said our domain was x cannot be equal to plus or minus 1, it means that this would be the domain of the function. All right, well, I'm going to do something that probably would be a good idea to start with, and I mean, I could be wrong. That could be the domain of the function, but that's not the way to find it. But let's just see. Okay, so I'm going to change my function now. Oops, to be f of x equals 1 divided by where's the cube root? Miscellaneous. Right there. The cube root of 1 minus x squared, 1 minus x squared. Oh, well, son of a gun. That is actually the domain. I'm surprised. It is negative infinity to -1, -1 to 1, and 1 to infinity. All right, is everybody okay with that? Okay, I'm gonna, can I take a tangent at the risk of confusing you and show you why I was a little bit concerned about that? All right. So I'm reluctant to do this, but I'm going to trust your powers of being able to take a tangent here. Let's say that instead our function had been 1 over the square root of 1 minus x squared. So I would do the same thing. I would have the square root of 1 minus x squared cannot be equal to 0. I would square both sides, and I would get 1 minus x squared cannot be equal to 0. So x squared cannot be equal to -1, negative x squared. X squared cannot be equal to 1. So the same thing, if I take the square root of both sides, it would have x cannot be equal to plus or minus 1. And again, if I take that as my domain, I would go negative infinity to -1, union, -1 to 1, union, 1 to infinity. But if I was to graph that, I'm going to graph it as the square root. I find that the domain is actually just -1 to 1. There is nothing on this side or that side. Are you still with me a little bit? Okay, so I want to show you the proper way to find the domain when I have something like that. And this is troubling me a little bit. I'm thinking, in case you can't tell. Okay. Now, actually, okay, I've just recognized what my problem was. So this is actually the domain of this function. This is actually the domain of this function, right? Because we have an equal sign here, we can do what we just said and what Megan said is true, that x cannot be equal to plus or minus 1, and that's what our graph showed us. All right. So where I was okay. So I solved the domain for the denominator part. Kendra, do you see a radical sign anywhere in this function?
Yes.
But does it have an even index or an odd index?
Odd.
So I don't need to worry about the fact that there's a radical sign. Is everybody okay with what I just said? I'm only concerned with the radical sign if it's an even index. Odd index, no problem. And so Kendra, what about logarithms? You see any logarithms in here?
No.
I don't either. Does anybody else see any logarithms? No. All right. So the domain of my function is exactly this negative infinity, negative 1, negative 1 to 1, 1 to infinity. None of these are included. None of the plus or minus 1 is not included in the domain of my function. We're okay with that. Okay. Then before I go back to this problem, I want to kind of go back to what I was trying to do over here. Okay? Because if this had been my function right here, if it had been a square root as opposed to a cube root, then I would have had to answer the question, is there a radical sign with an even index? Yes, there's a radical sign with an even index. And when I have a radical sign with an even index, the radicand has to be greater than or equal to 0. So I would have 1 minus x squared greater than or equal to 0. Are we okay with what I just said? Yes, right? Because I can't have the square root of a negative number. What is dangerous here, and it's when there's an even index, would be to just do the same process as if it was an equality sign, and then say negative x squared has to be greater than or equal to negative 1, and then multiply both sides by negative 1, and say x squared has to be less than or equal to positive 1, and then take the square root and say x has to be less than plus or minus 1. That would be wrong. That would be the wrong domain. That would be a domain essentially saying that x had to be less than or equal to negative 1. But if you have a radical sign with an even index, and you're solving for the domain by this equation right here, or this inequality right here, the way to do it is you have to treat this as a polynomial inequality. It's not a linear inequality. You have to treat it like a polynomial inequality. So this is where we're getting into some algebra here. Do you remember, anybody remember polynomial inequalities? Last from pre-calculus? Yes? Nobody remembers it? Good, we're gonna remind you, all right? To solve a polynomial inequality, you have to get everything on one side and the other side set it to 0. Gesundheit. Then you need to find what are your zeros of this part of the function. Well, if I'm finding the zeros, I can actually follow this progression right here. I can find out that, well, 1 minus x squared, let's set it equal to 0. So negative x squared equals negative 1, x squared equals 1, x equals plus or minus 1. But that finds the zeros. Then I need to do the number line thing. 0, 1, 2, 3, negative 1, negative 2, negative 3. And I know my zeros are at plus and minus 1. So I have a 0 here, and I have a 0 here. And I'm trying to solve this inequality right here. I'm trying to find out where is this function greater than or equal to 0. Well, I got it. I have intervals, and I have to pick numbers and try them. So I'm going to pick negative 2, 0, and positive 2. And I'm going to stick them back into my function because I'm trying to find out where the function is greater than 0 or less than 0. So I have 1 minus negative 2 squared. That's going to be a negative number. I have 1 minus 0 squared. That's going to be a positive number. I have 1 minus 2 squared. That's going to be a negative number. The only place where this radicand is greater than 0 is between negative 1 and positive 1. That's the only place that it's greater than 0. That's why the graph of this function, where it's a square root, only goes from negative 1 to positive 1. It doesn't include all this less than negative 1 and all this greater than positive 1. All right, I need to pause right there. I mean, that was a very long tangent. But if you're going to find the right domain of the function, that's really the only way to do it. So in the chat, 3, oh yeah, I got this, no problem. 2, I don't know, kind of iffy. 1, like totally lost. And you can just send it to me personally if you want, if you don't want everybody to know whether you're a 1, 2, or a 3.
Wait, Mr. Jenkins,
Yes, please.
can I just confirm like what we did generally?
Go for it, please.
Okay, so since we had a radical, or yes, we had a radical sign in the denominator with an odd index, all we really had to do was set like the whole denominator equal to 0 and then find the x value. And then we went on a tangent, which was if it was an even index, then we would have to take everything inside the radical to set that equal to 0 and then find that.
Close. So we have
Okay.
to, if it was with an even index, we have to do 2 things. One, we have to do really the same thing that we did here and take the whole denominator here. Well, let's go back to the function that we're working on. Take the whole denominator here and say this cannot be equal to 0, right? And that told us that x cannot be equal to plus or minus 1. Okay? But then the second thing we had to do, because we had it, that's solving for the denominator, or the don't in the don't ride lions. We have to go for the ride with the radical sign. We have to take the radical sign, and we need to take the radicand, which is just the part under the radical sign. And we have to set it as an inequality greater than or equal to 0. And that's where we have to go through all the steps of solving a polynomial inequality, where you find the zeros and then you test the intervals to find out whether it's greater than or less than 0. Is this kind of beginning to stir some, cobwebs from pre-calc a little bit? Yes? A little bit. All right. And so the interesting thing here, Kendra, is that when I did this, when I found the polynomial inequality, I found that the domain of the radicand was actually -1 to +1 included. But as part of my function here, it's a denominator, and -1 and +1 are excluded. So the domain of this function right here is simply -1 to 1, not included, parentheses on both sides. So it's a little bit complicated. There's a lot of you got to do number lines for the polynomial inequality. You got to do number line for that. We're going to do number line for the extrema. You got to really kind of know your different steps here. And I'm going to make a statement that if you just try and memorize the steps, you're not going to get very far. If you understand the steps, then you'll be able to follow it. But it does take a little bit of thought. Okay, again in the chats, give me like 1, 2s, and 3s, or 1.5s, 2s, and 3s. Let me just kind of see where we're at here so I can decide what to do next. Okay, good. Okay. All right, so we're gonna do something there. Excuse me. 5.1. 5.1. So, okay, so what we're going to do is this. We're going to, no, we're here. Okay. We will finish this problem on Wednesday, but I am going to give you a problem to do at home. Okay. And that problem is going to be this right here. Wondering what the square root of. Okay. F of x equals 1 divided by the square root of 4 minus x squared. All right. Now I will tell you, this problem is in your book on page 195. And really what I want you to do at home, and where you can work the whole problem, that would be awesome, right? But what I want you to do at home primarily is I want you to find out, I want you to do the domain of f, the domain of the derivative, and I want you to find the derivative. I want you to do at least that much. If you want to finish the problem and find out what are the extrema, etc., that'd be great. But you can see I'm picking this problem here because I have a denominator and I have a radical sign with an even index. Right. So I want you to take a little practice on that. And it's a good thing that I recorded this because if you want to kind of look back at the recording and kind of follow how we did it, you can do that too. So everybody wrote it down? Yeah, pretty good. All right. I don't want to overburden you with a lot of extra work. Okay, any comments? No, we're hanging in there. That was kind of intense, yeah? That was a little bit intense, a little bit. All right, what is it? Is it lunchtime? You got 5 extra minutes for lunch. So by putting up with all my nonsense there, you win 5 extra minutes. So we'll see you later.